Hello, this is my Python block game. It's a 2D platformer with a randomly generated environment and world. I'm going to go over some of the more interesting aspects of it. This video is meant for people who have coded before, which means that some of the more simple elements of it are going to be left out for time and entertainment's sake. The main focus of the project was on world building and rendering, so a lot of my code might seem unnecessary or sloppy, and this is due to me not really knowing where or how far I wanted to take things. So I had systems laid out in some places that I never really needed them, and in other places I didn't have those systems put in where I really should have. It's definitely been a learning experience on the importance of laying out these systems that make introducing future parts of the project cleaner and more understandable. So let's go ahead and get into it. The world is basically a giant grid with blocks, and there's different types of blocks: air, water, grass, stone, and they all have different matter types: solid, liquid, or gas. The idea of splitting them up like that is so that I can make gases behave similarly, liquids behave similarly, without having to specify it about each specific block. An example of this is how liquids and gases do not cause collision, whereas solids do. How collision is detected is my favorite part of the project. When a movement key is pressed, the game will call a status function in the player class with a corresponding number that tells the function what's happening. Figuring out what to do is reliant on if the player is touching a solid block or not. The easiest way to figure this out would be to check all the blocks to see if their coordinates are intercepting the players. However, this would be very inefficient and likely cause a lot of lag. So in order to solve this problem, I created a zone system. Based on the player's size, blocks are grouped inside the player class in what I call a zone. 4 of these zones are loaded at a time around the player from the zone grid. All of the blocks inside the 4 closest zones are what get checked for collision. There's a few different sets of coordinates that get used to navigate the position in the game world. There are pixel coordinates, referring to where something is in the world pixel by pixel. This is how the game knows the position of the player. There are the grid coordinates, referring to the position of the blocks and where they are relative to one another, which is basically the same as the pixel coordinates, just divided by the length of the blocks, which is 32 pixels. And lastly, there is the screen coordinates, which have to be calculated from the other coordinate systems to know what to display and where. It figures this out by using a couple variables called the camera mods. The camera mods are basically values that stay very close to the position of the player in the game world, so that the world class can use these values to only render blocks around the players and save a lot of frames. Other parts of the project, like rendering the hills and lakes and evaporating water into clouds, were challenges of their own, but a little bit tedious for an intuitive explanation. And in order to make everything smoother and simpler, I would have had to plan much further ahead than what my original ambition accounted for. I love implementing clever systems to get things done, and overall I really enjoyed this personal project.